Pencil sharpener's over there by the door. You betcha. So yesterday we did two things. I went over the answers. I provided you the answers to the BEDMAS. And since so many of you guys were done that, I jumped ahead and we did simplifying fractions. Are there any questions that anyone would like me to go over from either the BEDMAS section or this page was the only simplifying fractions page I wanted you to do? Questions, comments, concerns? Take a look at my answers. Compare them with yours. And from here on out, all your fractions need to be reduced. Always. Hayden, pull your desk back so you can actually give Gabe some space. There is no reason why your desk should have been as forward as it was. If your shoes are going to be a daily problem, I will take them from you to start class. You can have them back at the end. Because every day it seems to be you and your shoes. Yeah, don't do that. Tie them tighter. Tie them tighter to start with. Also, Hayden and Oliver, get your notepacks out. Okay, if there are no questions, let's take a look at the next chunk. We're going to look at converting between fractions, mixed and improper, improper and mixed. And then I'm just going to give you a whole bunch of these questions to practice, and we're going to call it a day. So, even if you've worked ahead, I want to make sure you're with me. You filled out what I want you to fill out here. Let's take a look. We are, come on PDFs, don't be silly. I want this one. Okay, so, yes. I like pizzas. Pizzas are a convenient way to demonstrate the creation of fractions. If I have one whole pizza, we can represent this as one whole pizza. Shobit. I told you he was going to show up for you. Mr. Byring, this is the block. How about he meet? Oh, yeah, you can come to him. Okay, if I take my same pizza and I cut it into 2 equal slices, if both of those slices are present, I can represent this one pizza as 2 slices present of 2 slices whole. Or I can still refer to this as one pizza. These are equivalent fractions. And if we talk about fractions as being division, which we've done already, 2 divided by 2 is 1. You can jump back and forth between these two representations. It's fine. The same can be said for something like this. If I have the same pizza cut into 4, I could represent this as I have 4 slices of the 4 that are available. They're all still there. This is still equal to 1 whole pizza. But what if I have multiple pizzas and not all of the pizza? So something like this. If I have a whole pizza and a half a pizza, I can represent this as 1 whole pizza and 1/2 of a pizza. This, we don't write them so far apart. We call it 1/2, and we call this a mixed fraction. We've seen it already. We've looked at it. Now we're going to convert back and forth between them. What if I have this? I have 2 wholes and 1/2 a pizza. What mixed number am I going to call that? We're going to leave it as a mixed number. How many wholes do I have here? 2. And what fraction of a pizza do I have here? 1/2 of a pizza. But if I took those same 2 wholes and I cut them into the same fraction that this is here, they'd look like this. I took these 2 pizzas, I cut them into halves. How many halves do I have? Yes, Gabe. I'm going to assume that's not just a hand. I'm going to assume that hand is also the answer. This represents 5 halves. Now, it's important to recognize that this is the same amount of pizza. 2 wholes and 1/2 a pizza is the same thing as having 5 halves of pizza. And so what we're going to look at today as a review, because you've definitely done this before in middle school, we're going to review converting back and forth from mixed numbers, something like 2.5, to an improper fraction, 5.5. When you're ready, flip the page. So the technique for this is simple. There's not a lot to do here. To go from mixed to improper, we want to make sure to do the following. What do you remember? How do I convert from mixed to improper? Not improper.
Multiply the whole number by the denominator.
I multiply the whole number by the denominator. So I'm going to take these two, and I'm going to multiply them together. So multiply the whole by the denominator. In this case, 2 times 2 is 4. And then what am I going to do with that result? Well, it says here to add the answer to the numerator. So we're going to add this way. 2 times 2 is 4, plus 1 is 5. And the denominator stays the same. So 2.5 represents 5 halves of something total. Relatively straightforward. So what would this thing be? I'm going to take my denominator and multiply it by the whole number. I'm going to add it to the numerator. What do I get? I'm going to get something there, and we're going to add it that way. Hayden, 5 times 3 is?
5 times 3 is 18.
Plus 3 is? So this thing's going to become 18 fifths. Nice and easy, relatively straightforward. Now, the fun comes when I start to tweak these questions ever so slightly, and I give you something that looks like this. I'm going to toss another example over here. What happens if I make this whole thing negative? Let's take the same question and say, okay, well, I've got negative 3 and 3 fifths. How do I deal with this? What do you think, or you can answer this question. There is a very common mistake I see with this question that you don't see with this question. Does anyone want to see if they can come up with a mistake? Hayden. You're scratching your eye. Okay, that's fine. Yeah. That's the mistake I see. Someone, and I asked this question slightly differently in my A block class today, and someone actually made the mistake for me. It was beautiful and perfect, especially which student it was. It couldn't have happened to a nicer guy. So I felt really bad for him because he is actually a really nice guy, and he made this mistake in front of everybody. But it was a great way to demonstrate it. Often what I will see is students will go, okay, 5 times negative 3. If they do the 5 times negative 3, what are they going to get? Negative 15. And then they're going to add that to the 3. What is negative 15 plus 3? Negative 12. So often what I will see is students will make that mistake, and they're going to tell me, oh, this is actually negative 12 fifths. But we just did 3 and 3 fifths. 3 and 3 fifths should be 18 fifths. So if I just make this whole thing negative, then what should our answer be? It should be the same fraction, 18 fifths, just made negative. The thing that I often see is they'll take this, they'll say 5 times negative 3 is negative 15 plus 3 is negative 12, and they'll get this result. What you need to remember is that that negative actually applies to the entire mixed number. And if you're going to convert a negative mixed number into an improper fraction, you start by ignoring the negative, convert it into the fraction, assuming it was positive, and then reintroduce the negative at the end. Getting you what you should have started with in the first place. Does that kind of make sense? You identify the mistake? No, don't make it. So what I'm going to do here is I'm going to give you a couple minutes. I want you guys to crank out these 9, and I'm going to make these bottom 3 negative. And it says G, H, and yeah. Oh no, it does. It says labeled right. A, B, C, D, E, F, G, H, I. I want you to take a look at all of those. Crank out those 9. You've got, I don't know, I'll give you 3 minutes. That's 20 seconds a question if you haven't done it already. Fantastic. Just tweak these now because now I want these to make the change to the question, and then just make the simple tweak to your answer. Yeah. If you've done them already, also make sure that they're in lowest terms. So many of you are done them already. It's great. Okay, so lots of you are done them. If you weren't done them, you should be nearly done them. Be able to crank out these 9 questions like that. Is review of middle school. Speed up. You can't tell. I want to go a little faster. There's some base ones that I really memorize. Those are the ones here. The ones I'm expecting you guys to memorize are your nights. Every night is whatever the numerator is. So 1 night is 1, 2 nights is 23, 3 nights, which is also a third. 2 sheet is 23. All the so 9 over 9 is 0.93, which is actually pretty correct. So the nights are easy. Quarters you should know. It's money. 0.25, 0.5, 0.75, 1. Which makes your halves easy. 0.5. The sixths aren't bad because you do your half or your thirds and your half. Because 1/3 is 2 sixths, so 1/6 is half. There are techniques for bouncing back and forth. I'm not going to ask you things like 7s. 8s are easy to go to because you have to do that or half 25 to 12 and a half. So there are some easy base ones that I want you to memorize, and then you can extend them from there. Okay, so yes, always. But none of these questions, none of these ones should be reducible. Because I don't think any of them started reducible. So here's what you should have gotten for these ones. This one should have been 5/3, 5/3, 9 halves, 23 sixths, 23 elevenths, 16 thirds, 7 thirds, negative 31 over 10, negative 28 over 13, and negative 38 over 7. That is what you should have gotten for all 9 of those. Would anyone like to see any of those in more detail, or are we good? Some of us just need to work on, not stopping to smell the roses on the way to doing the math problems. Okay, flip the page. Going the other way. Here's how you go the other way. Again, this is review of stuff that you've done before. To go the other way, to convert an improper fraction to a mixed fraction. Yes, sir. Can you do what? Can you wait 10 more minutes for me to finish? Because I'm done the lesson in about 10 minutes, and then the rest of the class is going to be for you guys to work on stuff. Here's what you're going to do. If I have 11 halves, what we need to do is we need to figure out how many wholes I can pull out of 11 halves. How many whole groups of 2 can I pull out of 11? Or another way to think about it is, what can we multiply the denominator by to get as close to the numerator as we can without going over? It's like Price is Right, which is really sad because Bob Barker is dead, which is hilarious because he died at 99. So he got as close as he could to $1 without going over. It couldn't have happened to a nicer guy to die at 99. I don't want Bob Barker to be dead, but he is. But he died in the best way possible. So, what is the biggest, I know it's dark, right? What is the biggest number we can get that is a multiple of 2 that's smaller than 11? It's 10. So what do I have to multiply 2 by to get 10? 5. And so when I convert this thing, what we're going to do is we're going to pull out those 10. 2 times 5 is 10. So the 5, the thing that we multiplied by to get 10, becomes the whole number out front. So because 2 times 5 equals 10, this becomes the whole number that goes out front. And then what we're going to do is we're going to take the numerator and subtract it by the nearest whole number we used. So 11 minus 10. 11 minus 10 is 1. And the denominator stays to represent the fraction that we started with. So 11 halves is the same as 5 wholes and 1 half, or 5 and a half. Again, this is something that you would have seen a whole bunch in middle school, I hope. You're supposed to. So this is the technique we're going to use. I'll show you 2 more examples, and then I'm going to free you to practice a bunch of stuff. Here you go. I think actually, yeah, I'm going to practice a bunch of stuff. Okay, so if the mental math is something we don't enjoy, that's fine. We have our multiplication table, or you can write out the ones you need here on the side. If you don't remember whether or not 15 is a multiple of 3, just start cranking out the multiples of 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15, which incidentally is all listed here on your multiplication table for those of you who don't want to do the mental math. So now, if I wanted to convert 15 thirds into a mixed number, 15 happens to be a multiple of 3. So how many wholes can I pull out of 15? Yeah. This many. Yes, Gabe? Yeah. So 15 divided by 3 is 5, with 0 thirds left over. You'd never write the 0 thirds. So we would just say, if I'm converting 15 thirds, if I asked you to convert that improper fraction to a mixed fraction, you would just need to recognize that that's just a whole number. 5 is the same as 5 and 0 thirds. That's all you'd have to do. That's really boring. Let's make this more interesting. And look at 14 fifths. Well, again, if the mental arithmetic is something that we weren't trying to avoid, we can write it out. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. So the largest number that we can pull out of 14 that happens to be a multiple of 5 is 10. And to get 10, I had to multiply 5 by 2. So what we're going to end up doing here is we're going to write down the number that we multiplied 5 by becomes the whole in our mixed number. And what do we have left over? Well, 14 minus 10 is 4. So we're going to get 2 and 4 fifths. Comments, questions, concerns about what I've just done? We are relatively comfortable with this? Okay. Well, I'm going to walk around and make sure we are. Before you go any further, I want you to crank out these 6. What I want you to remember, though, some of these are not in lowest terms. You need to make sure that all of your answers here are in lowest terms. So if you ran ahead and and we're like over the last couple days have been just racing through stuff, I want you to go back and take a look at these 6. These 6 need to be written down in lowest terms. I'll give you 5 minutes to do these 6, and I'm going to write them down here as well. I got this. If you've already done them, again, make sure that you're in lowest terms. Yes? What is the biggest multiple of 5 that's smaller than 12? The one from the third. 5 goes from 5 to 10, 15. 10 is going to be the biggest one. So 10 is what's going to end up taking it. How do you, what do you get multiply 5 to get 10? The 2 is being like the whole number here. And 10 fifths, so what we're pulling out here, so you're 12 minus the 10 is 2. So you're going to and the denominator stays the same. The 12 fifths is going to become 2 wholes and 2 thirds. Yeah. Almost. The fraction part's right, so the whole part's not. So what you've written is you said, okay, you can take 5 roots of 5 out of 12. Which isn't true. Because 5 roots of 5 is 25. You took 2 roots of 5 out of 10. So that 2 there is what's going to become 4. And then 12 minus 10 is also 2. So whatever you multiply by 5, whatever you multiply 5 by, you get 10 is what the whole number is. Really 2. Because 2 times 5 is 10. And this is 2 because 12 minus 10 is 2. Try that. Let's see, we can still pull minus 10. Pull one more out. What is this? Seriously? All this? Oh, that's really cool. Okay. What's the rest of this for? Got it? Oh, it's a case. Interesting. Okay. Come on. Yeah. Once if you start on one more, you can text, which will be very short. Give me 5 more minutes and you can text your dad. Okay, so lots of you are done. These are the values you should have come up with. Take a look, comments, questions, concerns on any ones of those. The only one that I think you need to reduce is C, because if once you had done the mix, you would have gotten 2 and 3/6, which you need to make sure that 3/6 gets reduced to a half. I think the rest of it was straightforward. Questions, comments, concerns on any of those 6? Okay, then here's what I want you to do for practice. I am going to flip the page. If you worked ahead, then, well, you probably did more work than you needed to. On these first 9, A through H, what I want you to do are aces. Now, what are aces, I heard you say? Aces are, well, I can't talk about odd letters because there's no such thing as an odd letter. If I asked you about odd numbers, you'd say 1, 3, 5, 7, 9, and you'd go. Aces are A, C, E, G, I, every alternating letter starting at A. Basically, you're doing half the questions. So the first 9, I want you to do aces. The The second set of questions, I want you to do BDFs. So that one, that one, that one, and that one. I want you to flip the page. I want you to do aces here again. So A, C, E, G, I. And I don't know how this happened, but these ones down here should be J, K, and L. But just alternate the letters. So I want you to do aces there as well. Then I want you to flip the page again, and I want you to do this page. What is the difference between a 16-ounce brick and a carpenter? The way you do this question is that you take each improper fraction and you write them either as a mixed number in lowest terms or as a whole number. You find your answer down here, and then you write the letter, like the letter that goes with the question, underneath the answer. Here's what I mean. What is 9/4 as an improper fraction? It is, in fact, 2 1/4. So you'd find 2 1/4, and you'd put an S. And you'll do all those questions, and you'll figure out what the difference is between a 16-ounce brick and a carpenter. It'll be some sort of bad pun. I'm a huge fan of bad puns. And then, because you're almost certainly going to have the time, I want you to do this one too. To do this one, you're going to need a ruler. Why did the football coach send in a bunch of second-string players? How this one works, I have rulers. I have so many rulers. I have like 40 rulers. So how this one works is along the top ring, you simplify the fraction. So 10/25 is going to become, both those are divisible by 5, so 10/25 is going to become 2/5. You take the dot for 10/25, you find the dot for the answer 2/5, and you connect them with a line. Each line is only going to go through one number and one letter. So box number 16 is going to be letter E. And that's how you do that one. You've got lots of time, 40 minutes. Aces, BDFs, aces, and then 2 of these puzzles. You should be able to get most of, if not all of that done in this time. If you need a ruler, there's going to be up on the front table on your mark it set giver. If you need a hand with anything, please let me know. Oliver, can you text me? Now's a great time to do it. Whoever needs to go get a drink, now's a great time to do that too. You want me to help you before you go, or you want to come back and get help after? Okay, go get your drink first.